when I play the game, we will see that we have a player who has melee combat system, and we can also dodge our enemy who is currently standing because his state is idle. And yes, I have implemented the state design pattern here because we also learn clean code and how to write or best coding practices. And if I get close to the enemy, you will notice now that he is going to attack me. He has a long range attack and a short range attack. I can also focus on the enemy, and now when I touch him, look at that, when I attack him, we have this really cool camera shake effect. And also when the enemy attacks us, look at that, so the player is reacting to his attack by going a little bit backwards and all of that stuff. You get the point, how the boss fights usually go in every single game. I'm also going to show you this feature, which is first selecting the enemy, and I'm going to duplicate the enemy. So now we have two bosses. And now if I can, well, I'm going to move this boss far away so that you can see how we can focus on different game objects or different actors in the game. So currently I'm focused on the actor who is right there. Look at that one. And when I move my focus, I'm going to focus on the second one, but I need to get close to him. So now I'm focusing on the second boss. You get the point. I can cycle between focuses on the actors in the game. Now, before we start, I want to point out 4 things. Number 1, this whole system is created with C++. Of course, we have blueprints in the mix, but the majority focus is on C++. So if you don't know C++, make sure that you follow the basic C++ tutorials on my YouTube channel to learn before you start doing this tutorial. Number 2, this is not a beginner tutorial. If you're a complete beginner, don't try to create this. You will get lost. This is for intermediate and advanced people who have already been using Unreal Engine for a while. Number 3, in order to follow along with the tutorial, you will need to download the starter project, and link to that is down below, or simply go on my website, awesometuts.com, sign up, and you will get a link where you can download the assets. And number 4, make sure that you like, subscribe, and all of that stuff. You get the drill. Show some love, spread the word, help me grow, help you grow, and whatever. Anyways, that will be it, and I will see you guys in the next video part of this tutorial. Take care. What is cracking, peoples? Now let's get into the juicy stuff. First things first, you can download this starter project to follow along with the tutorial. Link to the project is right below the video if you are following this in my Game Development Academy. If you're following this on YouTube, then you will need to go on my website, awesometuts.com, sign up, and you will get the assets. Now, one thing that I'm going to do first is go here under Window Developer Tools. If you don't know this, you can go here under Widget Reflector. And here for the application scale, you can scale it to, a larger size, as you can see, and then the editor will be larger, more visible, and I like to work like this. So the first thing that we are going to do is open our Visual Studio. So double click here, open Visual Studio, because we are going to work with AI. We're also going to work with cameras and stuff like that. So we need to go over here in the .build file. So let me just click on that bad boy. And over here for our public dependency module names, add range and stuff like that. So we're going to simply copy and paste this one. Now, if you don't see it, I'm going to zoom in. And if you don't know how to do this, how to resize the font, I'm basically holding Control and scrolling the mouse. So this is scrolling up, scrolling backwards, and there you go. So there you go. Over here, you can pause the video and you can copy and paste all of these dependency module names. So we have here head mounted display. What did I add here? AI module and gameplay cameras, I believe, is the only one that is added. Anyways, that would be it. So now what we are going to do is go back into the editor. And from here, I'm going to right click and create a new C++ class. It's going to inherit from the character, so that is important. Click here next. And I'm going to call this one combatant. Now this is going to be the base class for the enemy as well as for our player. I cut out the video so we don't have to wait until the script compiles. And anyways, here is the script, and reload all. As I was saying, the combatant is going to be the base for the enemy and for the player. So it's going to have some common functionality. Now, in the folder that I have provided for you to download, what you are going to do is open the combatant.h file, which is this one over here, and you also have the cpp file, which is this one over here. And we are first going to copy everything from the .h file, so simply copy it and go here in the combatant.h, select everything here and paste it. Then we are going to copy the code from combatant.cpp file, go into that file and simply pasted, and that would be it. Now, the reason why I'm doing this, because as I said and noted in the beginning, this is not a beginner course, this is an intermediate level, so I expect you to know what is a player input component, what is a boolean, what are variables, what is an anim montage over here, also some other stuff like what is a U function, what is blueprint callable, and stuff like that. So I do expect you to know these things. And here you will notice, or you will see, that we have all of the variables that we are going to use. So over here we have the target locked, which we are going to use to check if we have locked on the target. As we saw in the preview, we can lock on the target, which is our boss, and you see this in a lot of games, so I'm going to show you how to do that. We have the booleans here that will control the attacking, damaging, moving forward, and stuff like that. You can figure out from the names of these variables what we are going to use them. Rotation, smoothing, we have the attack animations here, stumble backwards animations, which are going to be played when we take damage. Over here we have the functions for the attack, launch, attack or end attack, set attacking, damaging, set moving forward, and all of that stuff. So instead of you watching me typing all of this out, which will take time and we will not learn anything in particular, I just wanted to, well, paste them right there. And you can explore here again and see by the names of these functions and variables, you can figure out for what we are going to use them. So going here in our combatant, we are first inside of the combatant constructor. So we're going to do a few things. Now over here also I have included all the imports from external sources that we are going to use. When I say externals, I mean game framework like character movement and all of that stuff. So everything is included. So what I'm going to do here first is I'm going to say target locked, and that's going to be equal to false. Over here, next attack ready is also going to be false. Our attacking, so this is basically setting up the default values when the game starts. And attack damaging, so attack damaging is also going to be false. We're going to have moving forward, that's going to be false. Moving backwards, so moving backwards is also going to be false. Rotate towards target, that's going to be true, because we are going to rotate towards target. Stumbling, that's going to be false. Rotation, smoothing, that's going to be 5. And last, rotation speed, that's going to be 0.0f. Now this is everything inside of the constructor for our combatant. Again, as I said, this will be inherited from the enemy or in the enemy class as well as in the player class. So we're going to have some common functionalities. Now we're here inside of the tick. After we call the super, we are going to say if rotate towards target, then we are going to call here look at smooth, which is going to look the target. In the case of the enemy, it's going to look towards the player. In the case of player, it's going to look towards the enemy. So going back over here in the attack, we are going to say attacking is equal to true when we call the attack function. Next, attack ready, that's going to be equal to false. And over here, attack damaging, that's going to be equal to false. And then we are going to empty the array, so empty array. I'm simply going to leave that here as a comment, and we are going to say attack hit actors empty, and not employees but empty. There you go. Now attack hit actors is where we are going to store all the actors that we hit when we attack, and we will see that when we start battling all of that stuff. Now in the attack lunge, we are going to first test if the target is not equal to null, meaning the target that we are supposed to attack. If it's not equal to null, we are going to say f vector, and I'm going to call a direction, which is going to be equal to target, and then over here we're going to get the actor location. There you go, and subtract from it the actor location. So from here, subtract that, and there you go. So from the target's location, we are going to subtract our current location, and this is how we are going to get the direction. And be that in Unreal, be that in Unity, in order to get the direction from one object towards another object, we simply subtract their positions. And then we are going to say direction is going to be equal to f vector. And since I'm interested only in the x and the z, basically forward and left and right and forward backwards direction, I'm not interested in the up and down direction. So what I'm going to do is direction x and over here direction y. and 0 here for the z-axis. And then f rotator, I'm going to call it rotation, is going to be equal to f rotation matrix. So rotation matrix, and this is not Neo and taking the blue pill or the red pill, whatnot. No, don't get excited. I'm not going to pull you in the void. I'm not Agent Smith. So calm down, okay? From here, I'm going to say make from X, which is going to give me the rotation towards the player, or in this case, the target, be that the player or the enemy. So from here, I'm going to say direction dot rotator. And last but not least, set actor rotation. And here I am going to pass the rotation, and voila, there you go. So is it rotation? Yes, it is. Set actor, not transform, but rotation. There you go. The autocomplete is sometimes weird. I don't know why. Do not ask me. I did not create Visual Studio. It's not my program, so I don't know. You need to ask the weird people over at Microsoft, you know. So over here, then, I'm going to teleport the actor forward. So I'm going to say f vector, new location is going to be equal to get actor. So get actor location, not label, and plus, and from here I'm going to add get actor forward vector, and I'm going to multiply that with, so multiply it with 70. Like that. And this is the base that we are going to use. So this is to propel the actor who is holding the script forward when he attacks. Now for the player, we might leave it like this. For the enemy, we saw that the boss was jumping he had a huge jump towards the player when he attacked him. And then over here, set actor location, and it's location, not location rotation. I told you this autocomplete is weird. There you go. So set actor location, and there you go. And from here, I'm also going to say true. And this is, as I said, it is going to propel our actor forwards. So this, with using get actor forward vector, that is obvious that we are propelling him forward. But for the enemy, we will see how we are going to override this and make it even a larger jump. So over here, attacking is equal to false, and it's not attack, but it's attacking when the attack ends. And next attack ready is going to be equal to false as well. In the set damaging, we're simply going to say attack damaging is going to be equal to damaging, which is the parameter that we are passing over here. Set moving forward. From here, we're going to say moving forward is equal to is moving forward. Simple as that, straightforward. Here, moving backwards is equal to is moving backwards. There you go. Over here in the end stumble, we're going to say stumbling is equal to false. And inside of the next attack ready, we're going to say next attack ready is equal to true, to denote that we can attack basically after that. Now over here inside of our get current rotation, what I'm going to do is I'm going to say if rotate towards target, then we're going to say return last rotation speed. Otherwise, we're going to return 0. And in case you didn't know, yes, we can do this, because when we hit the return statement, if this return statement is executed, then we are going to exit outside of this function right away. We are not going to go down and execute this line of code. So that's not going to happen if it hits this return statement. And that will happen only if this if statement is true. If it's not true, then it will hit this return statement, and there you go. And over here in our look at smooth, we are going to do the following. First, we are going to say if our target is not equal to null, and if our target is locked, and we are going to say if we are not attacking, so attacking, and one more time over here, get character movement, and from here I'm going to say is falling. So all of this we're testing. So if the target is not equal to null, and the target is locked, and we're not attacking, and we're not falling, basically all of these 1, 2, 3, 4 conditions needs to be true for this one single if statement to be evaluated to be true. So what's gonna happen is we are going to create an f vector, and it's vector, and I'm going to call a direction, and that's going to be equal to target. And again, we're going to get the direction of the target. So get actor location and subtract that from the actor location. So location, and it's going to subtract the location of the target from our current location, and then I'm going to say direction is equal to f vector, and over here I'm going to say direction dot x, and here direction dot y, and 0 for the z-axis, and f rotator, rotation is equal to f rotation matrix colon make from x, and here passing the direction dot rotator, and there you go, and set. Well, actually not set over here, but first what I'm going to do is call the f rotator, smooth it rotation, and that's going to be equal to f mat colon lerp, and we are going to lerp from the get actor rotation towards the rotation that we have just created, and we are going to do that in a rotation smoothing multiplied with the get world, and we are going to get, or simply call delta times seconds, and there you go. So this is going to create a lerp that will go from this value towards this value in this timely interval. Next, what I'm going to do is I'm going to say last rotation speed, and that's going to be equal to smooth it rotation dot yaw, and I'm going to say minus, or that's going to be equal to rotation yaw minus get actor rotation, so get actor rotation dot yaw, and this is going to be our rotation speed because we're rotating the character left and right, and we're doing that on the yaw rotation, and from there we're simply going to say set actor rotation, passing here the smoothed rotation, passing the smoothed rotation. Now, so far so good. I'm going to go here and let's just compile to make sure that we didn't do any oopsies. I'm going to lower my volume so that we, don't, I don't know, damage our ears, whatever. You get the point. Anyways, what I'm going to do next is go here. So this is for the combat. Now, unfortunately, we cannot test this out right now because we are going to inherit this combatant. We will see that. So we will see everything when the time comes. Don't worry about that. So the first thing that I'm going to do right now is right click over here and create a new C++ class. And I'm not going to inherit anything from here, but click here, show all classes, and inherit from the combatant. And from here, I'm going to click on next, and since I have inherited the combatant, we are going to have all of these functions that we just created. If you don't know how that works, then I'm afraid you're not, at the level where you should follow this tutorial. So you should go back and watch my C++ beginner tutorial series. They are available in my academy and on YouTube as well. So over here, I'm going to create the enemy base, and I'm going to call it like this, enemy base, and create a class. And wait for it to compile and all of that stuff. I can sing to you if you're interested in that, but that will cost you extra because, I'm performing. That was my beatbox. Anyways, let me just go here and reload all. So here is the enemy base. We are not going to code anything at the moment because we're going to go back over here, and I am going to create another class. And this time over here, show all classes, and we are going to inherit the enemy base. So click here, inheriting the enemy base. That is inheriting the combatant. So we will have all the functionalities from both. And this one is going to be enemy boss. This is how I'm going to call it. And let's go here and create the enemy boss. Because again, as I said, we are going to have the combatant who is the base class for both the enemy and the player, because we're going to have similar functionalities in terms of attacking as we saw. Let's go here and reload everything. And this is our enemy boss. And there you go. That would be pretty much it. Now, this is when it comes to enemy. We're not going to code it right now, but we need to do this at the moment because later on when we test some things with the player, we will need the enemy for that. So I'm just going to get this out of the way right now. Now let's go here and new C++ class. And this time again, from here, we're going to inherit the combatant. So click on the combatant, click on next. And this one is going to be our player character. Now you can call it player character, you can call it knight, whatever. I'm going to point this out right now because this is a basic, well, I'm not going to say basic, but this is one system that I'm creating here. It has 5, 6, 7 classes, so I'm okay with naming here player character as player character. But if this was a real game where I have multiple player characters, I have a knight, I have a wizard, I have a witch, I have a whatnot, I would name this character appropriately. There you go, I cannot pronounce words. If this is the knight, I would name him player knight or simply knight or whatever. You get the point, because naming conventions are important, which I talked about in my academy for the design patterns and best coding practices in writing clean code with C++ and Unreal Engine. If you're not enrolled and watching this on YouTube, make sure that you check that out. Link is down below. So player character and create the class. And we will create this class, of course. And I'm going to sing to you, during that time. Just kidding. But anyways, you get the point. And there you go. So let me just go over here, reload, and voila, we are finally done. So we're not going to go through classes and stuff like that. Don't worry about that for the moment. So I'm going to remove here bosses, enemy, base, and all of that stuff. We don't need that. Even the combatant we will not need, because now we're going to code the player character. Now what I'm going to do is, again, we have the files over here. We have the player character and we have the player character hn.cpp. So make sure that is in the downloads folder that you downloaded along with the complete project and the finished project and all of that stuff. So make sure that you first copy all the content from the player character.h and then go here inside of player character.h, select here and paste everything. Let's go now and copy everything that we have in the .cpp file for the player character. So copy it, go into the .cpp file over here and paste it. And there you go. Now the last thing that I'm going to do to make sure that everything is okay, I'm going to click here compile to make sure that we didn't do any oopsies, that we can, continue doing what we are doing here, but you get the point. Anyways, let us just wait for it to compile, and basically I'm going to cut out the video now because it's getting too long, and in the next video we are going to start. There you go, the compile worked. In the next video I am going to go through the player character briefly, what we have over here, but you can also inspect it yourself, and then we are going to proceed to code it and then create the player character and all of that stuff. So I will see you guys in the next video. Of course, if something's not clear, make sure that you ask in the comments down below, be that on YouTube or in my academy, and I will help you out. And I will see you in the next video. Moving forward, in the previous video, we pasted everything inside of the player.h and cpp file. If you did not inspect the file, this is what we have here. So we have the spring arm for the camera, we have the follow camera, we have here the static mesh for the weapon, we have the sphere for the enemy detection collision, we have here some variables like base turn rate, lookup rate, and all of that stuff you can already assume for what we're going to use. I even added categories on basically every single one of these so that you can assume for what we are going to use them. Over here we also have the matinee, I don't know how this is pronounced, matinee, whatever, camera shake for the nice camera shake effect that we saw, and all of the bunch of other stuff. So detection collision for the enemy, or when we detect, well, where is the enemy, we have the attack, the roll, the start roll, end roll, and all of these functionalities. Now here in the player.cpp, I have all of the imports that we are going to use, and over here you will notice that inside of the player character constructor, I have initialized the capsule, I have set the base turn and look up rate, and I did not rotate. So over here I will not rotate when the controller rotates. Over here we have the character movement, setting the orient rotation to movement, which will rotate the character towards the direction where we're moving. The rotation rate, how fast the character will rotate, the jump velocity, and all of that stuff. Over here we have the camera boom. Over here we have all of these components that we use all the time, so it's nothing hard and stuff like that. Over here, if you're not sure what this setup attachment on the right hand item is, basically it will set up the weapon, so it will attach it on the mesh, which is the player, and it will attach it in the socket called right hand item. Now, if you are not sure what this is, basically it's a name of one of the parts of the 3D model, and I covered this in more depth in my academy, which you can check out. Link is down below if you are not watching this in the academy, of course. Now, over here we have the create default sub object for the sphere. We set it up on the, or attach it on the root component. We set the collision response channels. We set the radius and all of that stuff. Over here we also initialize these variables and initialize these variables as well. You can already see what they are from the names. So what we set up. Now over here inside of begin play, we attach the on component begin overlap. We add these dynamics, and for the end overlap as well. Now what we are going to do here is we are going to add all enemies inside of an array, basically a set. So here I'm going to say T set, and this one is going to be a actor, and it's going to be a pointer and near actors. Now, what is a set? A set is an array that is an expandable array, because an array is fixed. It has a fixed size, but a set, it's expandable. We can add in it more, elements and stuff like that. And it's a container, basically. So we can call it a container class, and we can use it to put actors or objects or whatever you want to put inside when the order is irrelevant. So when we don't care about the order, how the order of elements that are inside, if we don't care about that, we can use a set. Of course, there are multiple types of arrays that we can use. Anyways, moving forward, what we are going to do here is we're going to call enemy detection collider, and from here we're going to get the overlapping actors, and we're going to pass here near actors as a parameter because it is going to get all the actors. The enemy detection collision sphere is overlapping, and it is going to put them inside of this array. So now what I'm going to do is and I'm going to say auto, and this is going to convert into an auto variable. Basically, this is an auto variable that will convert into a type of variable that we specify on the other side. What does that mean? Well, here I'm going to say enemy actor inside of near actors, okay? So basically, this enemy actor over here, auto, is going to be the type of variable that are stored inside of this near actor arrays, and this is an A actor, and there you go. So over here I'm going to test if, and I'm going to cast that into an enemy base, and from here I'm going to cast the enemy actor. So if this cast works and the enemy actor, that's one of the actors who is inside of this array that we got from overlapping or calling the sphere collider, if that is the case, then I'm simply going to say nearby enemies, and I'm going to add the enemy actor. There you go. So simple as that. And that will be pretty much it. So the next step over here is inside of our tick function. This is what we are going to do. Well, basically, we're going to code the tick function. Now, below the super, we're going to call focus target, which is going to focus on the target. But later on, we are going to cover this. We're going to code this and see for what we are going to use it. Do not worry about that. Now, first things first, over here, I'm going to test if we are rolling. So rolling, not if roll, but if rolling. Over here, else if stumbling and moving backwards. There you go. So we're going to have if-else statements. We're also going to have another if-else statement. So else if over here attacking and attack damaging. So if we have all of that, and what is going to happen if we are rolling? Well, if we're rolling, we're going to move the character forward. So I'm going to say here add movement input. So add movement input, and I'm going to say here get actor forward vector, and I'm going to say here 600 multiplied with the get world, and from there get delta seconds. Basically, this is going to move the character in the forward direction by using, as you can see over here, 600 units, multiplying that with delta seconds. So 600 units forward, we're basically going to move our character. Now here, if we are stumbling and we are moving backwards, what's going to happen is that we're going to say add movement input, and from here I'm going to say the negative because we are moving backwards, get actor forward vector, and I'm going to use 40 and multiply that with the get world. Basically the same thing over here. So I'm simply going to copy this and paste it, and there you go. So we're going to move the character backwards if we're stumbling and moving backwards, and 40 units multiplied with the delta seconds, basically. Next, what we are going to do is here inside of our else if, we are attacking and attack damaging. We are going to create a set, an array. So here, T actor, and what's going to happen here, we're going to call it weapon overlapping actors. There you go. And we're going to loop through the weapon contacts and apply the damage. Basically, as you can see here, weapon overlapping actors. So I'm going to say here weapon, and from it, I'm going to say get overlapping actors, and passing here our weapon overlapping actors like that. What this is going to do is it's going to go inside or get all the overlapping actors from our weapon, and it is going to store them in the weapon overlapping actors array. So now what I'm going to do is say for every actor, so actor, and star, because it's a pointer, so we add a pointer, and I'm going to call it hit actor inside of the weapon overlapping actors. So for every actor that's inside, what we are going to do, first things first, we need to make sure that we don't hit ourselves. Basically, the player should not deal damage to himself. So we're going to say here, if hit actor is equal to this, then we're going to say continue. If you don't know what continue does in a loop, it basically skips that current loop iteration. So let's assume that this loop will loop for 10 times, and let's assume we're currently on loop number 8, and this is true. So hit actor is equal to this. We are going to continue. That means we are going to skip the iteration number 8 and exit out of the loop, and then go forward at the beginning and start loop number 9, and all the code that's below will not get executed. That is what we are doing here. So we're going to make sure that the character doesn't hit himself. Now over here, I'm going to say if with an exclamation mark, attack hit actor contains the hit actor. Basically, we are not going to allow to apply damage 2 times to the same actor. So don't hit the same enemy multiple times with one attack. Basically, this is what we're doing. So if the hit actors that are hit doesn't contain the current actor in this iteration loop, then we are going to apply the damage. So I'm going to say here float, not path, whatever I wrote here. So float applied damage is going to be equal to you gameplay statics, check the statistics, applied damage, and passing here the hit actor. So apply damage to our hit actor, and 1 point, so 1 is the base damage. Basically get controller here, who is the event instigator or the one who is dealing the damage. This here passing for the class, and you damage type, and this one is going to be static class. Simple as that. And this is going to call, if you don't know, when calling this you gameplay statics apply damage, passing here the actor, it is going to call the take damage. And let me just see where it is. Where did I put take damage over here? Here it is. This take damage function will be called on the actor that we pass here as a parameter, which in this case is the enemy. Now, over here, we're going to check if the applied damage was successful. So if applied damage is greater than 0.0, that means it is successful. We have applied the damage. So what we are going to do is we are going to call the attack hit actors, and we're going to add the current hit actor so that we make sure next time this here will not get, if the current actor is hit, then we will skip all of this here. That's why we're adding the actor that we hit right now. Next, we're going to shake the camera. So I'm going to say get world, and from here, so get world, and from here get first player controller that is, and from here player camera manager, and from here start shake camera. There you go. And this goes down here, and we're going to shake the camera, shake minor. Now we're also going to create this camera, so do not worry about that, or this camera shake minor. So we'll create it after we test the player, which is going to happen very soon after we code the movement functionality. Now outside of all of these if-else statements, which is right here, we're going to test if the target is not equal to null, with capitals all, and the target is locked. Then what we are going to do, we are going to call here or create an F vector, target direction. We're going to check the distance on the target within the X direction. So I'm going to say here target, and from here get actor location, and subtract the current actor location, which is the location of our enemy. or basically this is the player and the target is the boss. And from here, if target direction dot size 2D, and from here, if that is greater than 400, and basically size 2D, it's going to get the length of this vector, but on its x and y axis. So that's the size 2D basically, because that's what we are interested in. We are not interested on the z, which, you know, goes upwards. So what we are going to do here is we are going to rotate towards the target, which is the enemy, within y degrees. So we're going to say f rotator, and I'm going to call it the difference is going to be equal to u Kismet math library, and I'm going to say here normalize the delta rotator, and inside of this normalized delta rotator I'm going to call the controller, and from him I'm going to get the control rotation. And then I'm going to pass here target direction dot to orient rotation or orientation rotator. Basically, that's it. So this is going to give us the difference in the rotation between the control rotation and the target direction, which we are now going to use over here. So I'm going to say if f math colon absolute value of the difference for the yaw is greater than 30, like that, then we're going to say add control yaw input, and from here delta time, so it's delta time, and we're going to multiply that with the negative of the difference yaw, and multiply that with 0.5. So these are small calculations that I tested out that work in order to rotate the player smoothly, how can I say, towards the enemy character. Now, this will rotate towards the enemy character, as I said, if the target, so the enemy, is not null and we have locked. So we called the locked functionality to lock on him. Now over here, this is the player input. If I go back in the editor, you will notice that everything is set up. So if I go here in the input, you have here, everything is set up. Attack, roll, and all of that stuff. You see over here, move forward, turn, look, and everything, it's set up so you don't have to do that. Of course, you can change or add functionalities. For example, if you want to toggle the combat mode, I set that on the middle mouse button. You can set that on F. Roll is on the right mouse button. You can set that on Shift. Whatever your preference, it's not going to change anything except the button that you press, but everything is set up over here in our player setup input component, or setup attachment, however you want to call it. Basically input component. Anyways, setting up or attaching the functionalities, you get the point. Anyways, over here in the turn at rate, what we are going to do is we are going to say add controller yaw input, and I'm going to say rate and multiply that with the base turn rate, and then I'm going to multiply that with the get world, and from here get delta seconds. There you go. Now this is a function, so I need to call it like that. I'm going to copy this line of code and go over here and paste it, and here instead of yaw I'm going to add the pitch, which is going to rotate x and y. So this is going to rotate x and y, and this is going to be rotate multiplied with base, not turn, but this one is going to be look up. So look up rate, there you go. So we have the base turn rate, and then here we have the base look up rate, and we're going to multiply that with the delta seconds. Now when it comes to moving forward, what I'm going to do is I'm going to test, and here in parentheses, if our controller is not equal to null. So we do have the controller, and over here in parentheses one more time, if the value is not equal to 0.0f. And one more time over here, we are not attacking, and we are not rolling, and we are not stumbling, and you get the point. So if we do have the controller, and over here it goes and, if we have the controller, so he's not equal to null, and the value that is this here, which will be greater or less than 0, depending on if you're moving forward or backwards, and the value is not equal to 0, that is what I just said, and over here we're not attacking, notice the exclamation mark, which means we are not attacking, and we are not rolling, and we are not stumbling, then what we are going to do, we are going to say here constant f rotator, rotation, that's going to be equal to controller So it's basically controller get control rotation and constant F rotator. That's going to be called yaw rotation. So over here passing 0. We're only interested for the yaw. So rotation, rotation. There you go, yaw, and 0 for the Z. So now that we have the rotation, I'm going to create a constant F vector for the direction. So it's F vector. And that is going to be equal to ny. Okay, I saw here an error and I was like, what is happening? Anyways, direction, which is going to be equal to F rotation matrix. So F rotation matrix, passing the yaw rotation over here, dot get unit axis, and E axis over here. What are you doing? So E axis colon X. There you go. Let me just move this backwards. So F rotation matrix. What is this doing? Parameters, passing here the yaw, get unit, it's axes with I, not an E. So this is the problem that I had over here. So it's not axes. We're not looking for 2 axes. We're looking for axes 1. But it's pronounced basically the same. Anyways, next over here, I'm going to say add movement input. Movement input. And over here, passing the direction, then passing the value, which is going to make the character move. And last but not least, over here, our input direction that X is going to be equal to value that we need to specify over here. So now, since we are moving forward and doing, this, what I'm going to do is I'm going to copy all of this basically and go here in the move right and paste it. But here for the move right, what I'm going to do is instead of, well, basically everything here is going to be the same. Controller is not equal to null, and we have the value that is not equal to 0, and we're not attacking, we're not rolling, we're not stumbling. This is how we are going to get our rotation for the control rotation, calculate the yaw. Over here for the direction, we are going to pass here the yaw, but this time instead of X, we're going to use the Y, and that would be pretty much it. And also here for the Y, we're going to change it to the value. And that is, well, basically it, what we are going to do with the movement. So now that we are done with the movement, and again, this is just calculating the rotation and where we should go, and then calculating the direction based on that rotation, and which is going to simply give us the way where we are looking to go towards that way. Now, what I'm going to do, let's go back here in the editorial, and I'm going to compile everything, and we are going to create our player, so BP player, which is the blueprint of the player, and we are going to add his components, and there you go, compile has succeeded, which means I didn't do any oopsies. So in the blueprints folder over here, I'm going to right click, and let's go and create a blueprint class, and this blueprint class is going to inherit from the player character. So make sure that you do that, and then over here, BP player character, and double click it and open the player character, and let's go over here, compile and save. Now, before we code the player character, what I'm going to do is we are going to prepare the camera shake. So we are going to prepare it because, so let's go over here and let me just find the blueprint class, and here matinee, is it that? Matinee, I don't know how this is pronounced. I mean, you cannot write that. If you write it, I will still not know how it is pronounced. Anyways, you get the point. So let's create camera matinee shake, whatever. I'm going to call this one BP camera shake underscore minor, because we will need to attach this on the player, and I don't want to forget to do that so that we have problems later on. So over here, the duration is going to be 0.2 seconds. What I'm going to do here with these is on the pitch, I think, and on the yaw, we're going to change the value. So here for the amplitude is going to be 1. For the frequency is going to be 50, and random and sine wave, we're going to leave it like that. For the yaw, 1 and 50. So both are going to be 1 and 50. We're not going to touch here the roll. For the lock oscillation, we have on the X and on the Y. So over here on the X, I'm going to say 10, and then here frequency is going to be 1, random and sine, and for the Y, actually Y we're not going to touch here, but Z, and here for the Z, what I'm going to do is 1 and then 50. And there you go. And that will be pretty much it. So I'm going to compile and save that. And what this is going to do, well, the rot oscillation, so rotation, oscillation, and location. Basically, this is the rotation of the camera shake, and this is the position of the camera shake. So you can play with these values, which is going to distort the camera from its position and its rotation when we call the shake, and that's going to last for 2 seconds. This is basically what it means. Now, the reason why I created it, because now over here in our player character, when we select here the player character, you will notice over here inside of the camera, we need this camera shake. So I'm going to click here and select that camera shake so that we don't forget to do it later on. That is the only reason why. So there you go. So what I'm going to do now is go here, select the character mesh, and from here we want our base droid Mixamo rigged, which you can assume this is a model from Mixamo.com, which is a weird looking robot, and I'm going to set his position minus 97 on the Z and the rotation to 170. We still did not create any animations. We will do that later on. Do not worry about that right now. Over here for the weapon, I am going to set it to fire axe, and there you go. So this is going to be his weapon. Compile and save this bad boy. Now, before we test it out, I'm going to go here and right click and blueprint class, and this is going to be game mode, and here it is. And I'm going to call it BP Dark Souls boss fight underscore game mode. I'm just creating this. We're not going to need it for anything except to go here inside of maps and modes and call our BP Dark Boss game mode blah 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 and select the BP player character, who's going to be our main character that's going to be spawned in this level so that we can, you know, test the game out. And now we can run the game. So if I hit the play button, we will be able to test the game, and there you go. I can rotate on the character. I can move him. You see left and backwards. He's rotating towards the rotation, towards the movement, towards the rotation. He's rotating towards the movement. Everything looks smooth. And there you go. So we have the functionality for the movement. If something was not clear, even though these were, let's say, I'm not going to say basic stuff, but a little bit above basic, but still your level. So this is just, you know, calculating the rotation direction and moving the player. That's all there is to it. Here we have, you know, what we did here, we'll see later on. So this will come in handy later on when we start attacking, rolling, and all of that stuff, but you get the point. Either way, if something is not clear, make sure that you ask in the comment down below, and I will see you guys in the next video. Alrighty then, my game dev elves. Moving forward, over here inside of the blueprints folder, I'm going to right click and create a new folder. I'm going to call this one animation. So animations, there you go. I need to spell it correctly because I'm bad at spelling, I'm bad at everything. Moving over here again forward, because we already said that, I'm going to right click and go into the animation here, and I'm going to create the blend space, not blend space 1D, because we're not going to only blend one animation into another, but we're going to have multiple animations. And for this bad boy, we need to use the skeleton. Now for the player, we are of course going to use the player skeleton, which is this one bad boy over here. I'm going to call this one player underscore blend. This I'm going to call it, and double click it and open it. So first things first, what I'm going to do is over here on the left side under asset details and then axes settings, here we have the horizontal and then we have also the vertical. Now for the horizontal, the name is going to be sideways, and the minimum value is going to go from minus 600 towards 600. So from minus to plus 600. Over here, the number of grids, I'm going to set that to 8, which is going to change the number of these grids that we have over here on the animation layout UI, however you're gonna call it. The interpolation time is going to be 0.3, and averaged interpolation is going to stay as is. The name over here is going to be forward, and this one is also going to go from minus 600 towards plus 600. The number of grids is going to be 20, and interpolation for this one is going to be 0.2, and then save. So what are we going to do with these animations? Well, first things first, over here in the asset browser, I'm going to write walking and backwards. The right walking backwards is going to go here at the bottom left corner. So bottom left corner for the right walking backwards. Then we have run backwards. Over here, run backwards. And I'm going to put that right here in the middle. So run backwards. Then we have left walking backwards. Over here, I'm going to say left walking backwards. This goes at the bottom left corner. So these are for the corners of our animation. Next, we have the walking. So walking backwards. And this is the one that we want, walking backwards. And this one is going to go here in the middle. So let me just see how many grids. So from here, 1, 2, 3, and 4 grids. So it's going to go here. So 1, 2, 3, 4, and it's going to go on the 4th grid. Next, we are going to have left straf. So I'm going to call it left straf. So left straf backwards walking. And this one, so left straf backwards walking, this one is going to go here. So from our current, we're going to have 1, 2 grids. So this one over here, 1, 2, and on the 2nd grid, there you go. Then we're going to have right straf. So instead of left over here, we're going to have right straf backwards walking. And this one is going to go on the same, but on the left side. So it's going to be 1 and 2 grids. So here 1 and 2. When I say 2 grids, this is 1, this is 2, and on the 2nd grid, there you go. Next, we're going to have how is this called? Idle one. So let me just find the idle over here. So idle, and the idle is going to go here right in the middle. So 1, 2, 3, and 4, and this is the middle. So right here is the idle animation. On the right side of the idle is going to be right straf, and this one's going to be right straf walking. So it's going to be on the right side, and it's going to have 2 grids. So 1 and 2, and it's going to be on the second grid. And last but not least, we're going to have right straf, which is going to go here at the middle, so to say, but it's going to be over here. Actually, I'm going to move it forward. So there you go. So right straf goes over here. As you can assume, this is right straf walking. Now we're going to have the left straf walking, which is going to be on the left side of the, so walking left side of the idle. So 1, 2 grids, and there you go. And left straf, which is going to go right there. Next, we have the walking one. So over here in the assets, walking, and this is not the walking that or something like that. So calm down. So we have 1, 2, 3, 4 grids. So 1, 2, 3, 4, and on the 4th grid. And then we have the jog forward. So jog forward, and it's 2, 1, and 2 grids. So 1 and 2 grids. There you go. And the last but not least, we have the running. So running, it's not ruining, it's running. And the running goes in the middle here at the top. Where did it go? Here it is. And you can use this preview to demonstrate. This green one is preview. So look at here, we have walking, we have, jogging, and then we have running, and look at that. So this is how it looks like. Every preview of the animation, you can see how it looks like. And based on the values that are going here from -600 towards 600, and also here from -600 upwards to 600, depending on the value that we have, we are going to play the appropriate animation. Of course, this is just the blend for the player. Now we are going to go here in the animation and right click and animation class, actually not blueprint but animation. I said animation, I clicked on blueprint, so animation blueprint, and it is going to take the base droid Mixamo, because again this is the player and we're using both of these, or this model is used both for the player and the boss. So here I'm going to call it BP player animation. And let me open this bad boy. And the first thing that I'm going to do is add a couple of variables. So over here in the variables, this one is going to be is in air, which is going to do exactly that, what the name says. So is in combat mode. It's going to test if we are in the air, if we're in the combat mode, and there you go. So it's basically it. So next we are going to have 3 more floats. So click here forward, or actually click on the plus for the variable, and this one's going to be forward speed. Then I'm going to declare it as a float. Let me just compile and save that. Next we are going to have the sideways speed, and last but not least we're going to have the yaw speed. And let me just compile and save that. So inside of the animation graph, I'm going to right click over here and create a state machine. And the state machine, I'm going to call it player movement. So player movement, and the state machine is going to go towards the default slot. And I'm going to plug it in here, then plug it in here in the output, and compile and save that. Of course, we have warnings, because why shouldn't we have warnings? Why shouldn't we not? We did not create any animation. So over here we have the state, which is the idle / movement state. And this is the entry point of the animations. So what's gonna happen inside of the idle movement state? So over here, I'm going to right click and create another state machine. And this one is going to be the movement. And what's gonna happen in the movement? So let's go first, plug in this into the output. And the entry is going to go state, and here we have the passive idle, and I want to capitalize I. It's not important, but I like doing it like that. So passive idle, let's go here, come on. So copy and paste, and this one is going to be passive moving. Voila, there you go. So copy and paste one more time. No, not going inside of this one. So over here, let me just remove it. So combat idle, I said remove it, but I, wanted to rename it. So combat idle, and this one is going to be combat moving. So combat moving. There you go. So these are the animations that we are going to use. So the entry is going to go into passive idle. We are going to be able to go from idle to combat idle, and back from it, we're going to go from combat idle to combat walking, and vice versa. We're going to go from combat walking to passive walking, and vice versa. We're going to go from idle to passive moving, and vice versa. There you go. First things first, let's go here in the passive idle, and I'm going to find over here ax idle blend space 1. There you go. So this is another blend space that is already created. You can check it out. I didn't want to create every single idle space or blend space because it will take a lot of time for that, and I do not want to waste time on something that we will not learn that much. So there you go. Here we have the passive idle. Now let's go back here in the passive moving, and here we are going to have base underscore droid mixamo ax blend space, and this one's going to be plugged in here. Take the forward speed, which goes here, and take the sideways speed, which goes here. So plug them into their appropriate slots. This is for the passive movement. Next, we have the combat idle, and the combat idle over here is going to take the ax idle blend space 1. So there you go, and it goes here in the result. It takes the yaw speed, and that is going to be plugged into there. And last but not least, let's go here inside the combat movement. And for the combat movement, we are going to have the base droid and mixamo ax blend space one more time. And I'm going to plug this in over here. And again, we're going to have the sideways, which goes in the sideways parameter. And we have the forward, which goes into the forward. Make sure that you compile and save that. Now we do have an issue because we did not create any of these parameters that we need. So first parameter going from, and this one is going from passive idle to passive walking. So what's going to happen here is that I'm going to get the forward speed and I'm going to get the sideways speed. And I'm going to test their absolute values. So we have one absolute value from this one, and then we have the second absolute value from the second one. So from both of these, and I am going to plus them together. So plus equals the float. There you go. Absolute values, we know they're positive numbers. And if they are greater than or equal to 10, so over here, if they are greater than or equal to 10, that is going to be the parameter for this, for this condition. So make sure that you compile and save that. This is for walking from the passive idle to passive walking. So now going back from walking to idle, let's go here, and I'm going to paste this basically, because we are going to test not if it's greater than or equal to, but this time we are going to test if it's less than or equal to. And again, I'm going to pass here 10 and plug that into the can enter transition, because we are going back from walking to idle. If the forward speed and the sideways speed, the absolute values of them, and we have them, together, so plus equal, how is it called? We add them together, and if that value is less than 10, then we're going to go back to idle animation. So let's go here from combat, or back from combat to idle. What's gonna happen is I'm going to take here is in combat mode and test if we are not. So using the Boolean, if we are not in the combat mode, then we're going to go back from combat to idle. And you can assume that we are going to go from idle to combat if we are in the combat mode. So that is going to be plugged in here. Simple as that. You can also assume that we are going to go, so over here, in regards to the combat idle to combat moving, we are going to test the same thing over here. So we are going to test if the forward speed, absolute value, and the sideways speed, absolute value, and when we add them together, if that is greater than or equal to the value of 10. So if that is the case, then we are going to go from idle to combat movement walk. So from idle to movement. And let me just see here. So this one, if it's greater than, that is okay. But this one over here should be less than, yeah, there you go. I thought that I set the condition from going from moving back to this one, so I thought the condition was wrong, and that's why I went to check it back. So over here, going back from walking, combat walking to combat idle, let's go here and paste it, and this time we're not going to check if it's greater than or equal to. Simply now we're going to check if it's greater than, and if it's greater than 10, and we are going to plug this in over here, and that would be pretty much it. So let's go here. We're going to go from combat movement to passive movement if the is in combat mode. So here, not. So if we are not in the combat mode, we are going to go, as you can see, from our combat moving to passive movement that doesn't involve combat. Simple as that. And over here, we're going to test if we are is. So if is in combat mode, there you go. Compile and save that. And now every error has gone away. Now, of course, we are not finished because we do need to go here. We have the movement. We are in the anim graph. Actually here, and then we have the idle movement. We are also going to have more states. So over here we're going to have the start jump state, and this is going to be your assignment to create the jumping. So we have the start jump. I'm going to copy and paste this, hopefully. There you go. Jump loop, and last but not least, over here we're going to have the land, and we're going to go from idle movement to start jump, then to loop, and then to land, and from land we are going to go here in the idle movement. So for the start jump over here, let me just find the jumping up animation. Here it is. This is going to go here, and for our loop, let me just find here, it's falling idle. So falling idle, voila, there you go. And last but not least, for the land, let me just find it here. We have the jumping down, and there you go. So going back here in the player movement, we are going to have some, parameters. So we are going to go here if is in air is true. So this is going to be plugged in here, which means from the movement, we're going to go into the jump if is in air is true. Now going over here, we are going to get this. I'm going to say here, get relevant time or anim time. So anim time remaining, and this one is going to be from the start jump. And if that value is less than float, which is going to be 0.1, then we are going to go in the transition that will be into the jump loop. Basically, when the animation over here, so if the animation start jump gets to the play value that is less than 0.1, that means 90% of that animation has already been played, then we are going to go inside of the jump loop. From the jump loop, we are going to test here if is not in air. So when we are not in the air anymore, we're going to move from the jump loop and go towards the land animation. And inside of the land animation, we are going to test one more time, get relevant anim time remaining for the land. There you go. And if that value is less than the float, which is going to be equal to 0.1, then we are going to go back into the movement animations and simply make sure that you compile and save that. Now, as I said, you are the one who is going to code the jumping functionality. That is going to be your assignment. I'm not going to touch that because why should I? Because I'm going to give you an assignment. I'm the teacher here, okay? The bell doesn't dismiss you, I do, okay? When the video finishes, it doesn't dismiss you, I do. You're going to stay here and watch all my videos, okay? Anyways, so let's go back here inside of the player character and select the mesh here. And selecting the mesh here, the anim class, it is going to be BP player animation. And right away, you can see now the animation is working on the player. So make sure that you compile and save that. Now, before I wrap this video up, what I'm going to do is go here, select the character, which is this one. And now we are going to go here into the animations, and we have the attack animation, we have the combat animation, we have the take, hit, stumble backwards animation and all of that stuff. So what I'm going to do here is add 1, 2, 3, and 4. So the attacks, we're going to have 4 animations for the attacks. The first one over here is going to be standing underscore melee. And this one's going to be attack and then underscore backhand montage. There you go. So this is for the first animation, that is. The second one is going to be standing melee cross hit. It's cross hit, so cross hit montage. There you go. This is the second one. The third one is going to be standing melee attack horizontal montage. Voila. And the last one is going to be sprinting forward roll montage. There you go. For the combat, actually this is for the combat. So the combat is sprinting forward roll montage. Combat roll, this is going to be the combat roll. And here, the last one is going to be standing melee attack 360 low montage. There you go. So these are the attack or 4 attack animations. Now let's go here for the hit one. So 1, 2, 3, and 4. And these are going to be the hit animations. When we get hit, we're going to go backwards. And I'm laughing because I'm explaining that to you and you don't see me. And I'm, mimicking what is happening. I'm like going backwards, but you cannot see that. If you did, you would laugh. And let's go here. And what I'm going to do, first one is going to be front hit in place 1. So it's actually front hit in place 1. There you go. And we want this montage over here, not the one that goes from the enemy, but this one that goes from the character Braxton. See, game, characters, and Braxton. This is the one that we want. So again, let's go front hit in place 1. And as I said, take the one with the Braxton. There you go. Next, we have the front hit place 2 or in place, hit in place 2. And again, take the one from the Braxton, and here, front hit in place 3 from the Braxton folder, and last but not least, front hit in place 5. This one's going to be the 5 one. And there you go. So make sure that you compile and save that. So animations are playing. We are still not done with the animations, by the way, because we also need to go inside of the event graph and code our stuff. So let's go here in the player animation. And this is the anim graph. So let's go and switch over here to the event graph. And what I'm going to do from the event graph, I'm going to test is valid. And I'm testing here if the owner, so try get pawn owner, if he is the one who is valid. If that is the case, from here, I'm going to say set is. So set is in air. And I'm going to get here. So let's move this node, right click, and I'm going to try get pawn owner. And from him, I'm going to get the movement. So get movement component. There you go. This one can go a little bit down. Get the movement component. And from it is falling. Voila. And then I am going to plug this into this Boolean. So we are getting the is falling returns true if currently falling, and you get the point. So you see what this is going to do. So from here, I'm going to set forward speed. Again, so setting the forward speed, and I am going to try get pawn owner. And from him, I'm going to get velocity. First things first, so getting the velocity, and then I'm also going to get actor rotation. And by the way, if you spot that maybe you can rearrange things or do it better, code them better, that is your assignment. So watch out how I'm coding everything. Maybe I will leave something on purpose that can be done better. So I want you to do that, basically do it better. So from here, I'm going to say unrotate, so unrotate vector. And I'm going to pass this rotation. So it's going to unrotate this vector with the given rotation. I'm going to split the pin structure because now over here for the forward speed, I'm going to use the x-axis. And from here, set the sideways speed. For this one, I'm going to use the y-axis. There you go. From the unrotate vector of the pawn owner. Now, next, moving here, I am going to try get pawn owner again. So try get, if I can spell it right. So try get pawn owner, and I'm going to cast to combatant, and I'm casting the pawn owner to the combatant, and from the combatant, what I'm going to do is set is in combat mode. There you go. And how is this going to be set is I'm going to get target locked, which is the variable that we have defined inside of our combatant. So if we go here in our script and open the combatant.h, target locked, it's visible, it's blueprint read, so we can find it in the blueprint, which we just did, okay? Next, what I'm going to do is from here, get current rotation speed. And this is the node that I'm going to call after. So this goes here and this goes here. So voila. So this is going to get me the current rotation speed. And what I'm going to do with this is I am going to set yaw speed with the current rotation speed. There you go. So compile and save that. And this is going to set the values for the in air and for our forward speed, sideways speed, and the yaw speed, which are used as parameters for controlling the transitions of the animations. Now we're still not done because I'm going to go here and I'm going to do the following. I'm going to right click and go here, add anim notify event. And first we're going to have the attack end. Then here we're going to have the attack lunge. Then here I'm going to right click and go, and we are going to have start damaging and one more. And this one is going to be stop damaging. And also here we are going to have move backwards, and I can move these a little bit closer to each other so that we can see a little bit better and have, we don't need that much space. From here, we're going to have the try get pawn owner. And we'll see what we're going to do with this just a second. So moving forward, another anim event. This one's going to be backwards start. So add anim notify or anim notify moving backwards start. Then from here, we're going to have moving forward end. So it goes here, then right click one more time. Then we have the moving forward start. Right click one more time. We're going to have attack ready. So next attack ready, that is. And right click, and over here, we're going to have the stumble end. Voila, there you go. So what we are going to do now is cast this into the combatant. So from here, cast to combatant, and this goes here. There you go. And then we are going to call the end attack, because this is a function that is defined over here inside of our combatant. End attack, if I can find it, here it is, our end attack. If I go into the combatant.cpp and find the end attack, lunge, and here it is. It's going to set the attacking to false and next attack ready to be true. And if you don't know what are these anim notifiers, well, basically we attach them. And who are we casting? Well, we're casting this bad boy over here. So now we will not have any problems. The attack or animation notifiers are set into the animations, and I talked about this in my Game Development Academy. If you're not there, make sure that you subscribe and learn more. But basically on the frame of the animation, we set the notifier, and when that animation plays and gets to that frame, these notifiers will be called. Simple as that. So next, copy this one, and from here, I am going to call attack lunge. Voila, there you go. And copy and paste this one. Then from here, I can move these a little bit upwards so that we can see clearly. Then here, start damaging. So we are going to start. So set attack damaging. Because this is the start, we're going to set here the loop to true. Then I'm going to copy this and paste it. And now this goes here and the loop is going to be false, because this is stop damaging. And last but not least, over here we have the walk backwards. So we're going to say here, set moving backwards to be equal to false. There you go. And make sure that you move these just a little bit upwards and attach the try and get pawn owner on every single one of these. So make sure that you do that. Otherwise we will have problems, because we like problems apparently. So I'm going to copy this and paste it then here, and this one is going to be plugged in here. So now moving backwards is going to be true. Maybe I can move these a little bit along with the notifiers, so something like that. There you go, just so that we can see more clearly and see these nodes. There you go. So copy and paste, and then plug this in here. And this one is going to be set moving forward. And because here the forward ends, we're not going to do anything. Copy and paste. And then this is moving forward start. So here we are going to check the checkbox and make sure that you move these a little bit up. And then we have this one over here. So this is the next attack ready. And from here, I'm going to call next attack ready. Voila. And take these and just move them a little bit down, and then move these a little bit up. And the last node that we are going to plug in is the stumble end. And from here, end stumble, and voila. Make sure again that you plug in the try get pawn owner in every single one of these objects, or otherwise this is not going to work and we will have issues, and we will not, our code will not function well as well. Now I'm also going to notify for the, so let's go here, because what we need to do is we have two more notifies that we need to add, and that is roll start. Here it is. And we also need the anim for roll end. There you go. Because now over here, we need to cast to player character. This is where we have defined the roll start and roll end. And for this one, I am going to call start roll. There you go. Copy this and paste. This one is going to be plugged in here. and this object goes here, and from here it's end roll, and voila. That will be pretty much it for the animation notifiers. Now, as I said, if you don't know what are these animation notifiers, I have explained. You can learn more about them in the Academy. I don't believe I covered that on YouTube, in case you're watching this on YouTube. But anyways, what this is going to do whenever the animation gets to the point or to the frame where we set this notifier, so roll start, it is going to call the start roll, which is going to go inside of our class over here and start roll. It's going to call this start roll, and the other one is going to call the end roll, and the code that's here, it's going to be executed. Not executed like, you know, ending the life of this function, but it's going to be executed and run. And that will be pretty much it. So over here, combatant said moving backwards. There you go. And so I believe everything is, yeah, we set everything as it's supposed to be or supposed to be, and that would be it. If you have any questions in regards to animation, what we did, and so on and so forth, make sure that you ask in the comments down below, and I will see you guys in the next video. What is crackings, my game dev elves? Now that we are done with the player character, we are going to move on the enemy. Yay! Now open the downloaded folder and you will notice this here, enemy-base.h, and you will also notice enemy-base.cpp. So copy the .h in the .h file over here, and also for the CPP, make sure that you copy it in the .cpp file. This is again so that you don't watch me typing out all of these things and basically will not learn a single thing. And that is why I am cutting this, you know, for you so that you can actually learn something, and we will jump to the part where we will start learning. So that is the reason why. Over here, what we have from the interesting things is the state enumeration class. Now I talked about enumerations, especially in the design patterns, writing clean code, good code inside my Game Development Academy. So one of the patterns uses enumerations. Well, that is one of the ways how you can accomplish it. There is a better way how to do it, but we talked about enumerations there. We talked about enumerations in other classes in the Academy. So if you're not enrolled, make sure that you check it out. The link is down below probably if you're watching this on YouTube. If not, if you're in the Academy, I'm just rambling. Anyways, you have the idle, chase, and chase, close, far, attack, stumble, taunt, dead, and you can assume from the names what we are going to use them for. So over here we have the static mesh for the weapon. We have the state that is going to control our game, take damage that we will use to take damage, anim montage that we will use to play the animations. Over here we have the begin play and all of that stuff. So you can see from the names of these functions what we are going to do with them. Now we're here in the enemy bus. I have also included the includes. So we're going to start with the enemy base, and I said boss, but enemy base over here. So first we are going to create the weapon. So weapon is going to be equal to create default sub object, and is going to be use static mesh component. And from here I am going to paste the text, well, inside as the name, and the name of that is going to be weapon because this is a weapon in our game. How else am I going to name a weapon? And from here, weapon, so it's weapon, and I'm going to set up attachment. So set up attachment, and I'm going to attach the weapon on the mesh. So we are going to get the mesh in the socket named right hand item. Now again, I've talked about the socket names and what they represent. So they represent certain parts of the 3D model, and I talked about this in more detail in my academy. If you are there, you can see other courses, especially the battle ones, you know, the midgets where they are battling those small little Vikings, whatever they are. So you can watch that course. I covered that in more detail and show you how to set it up and all of that stuff. So over here we're going to say weapon. Next, we're going to say set collision response to all channels, and we're going to set collision response, overlap. So this is the response channel to all collisions. Basically, this means the weapon will overlap all other actors and we'll be able to detect collision when it does. Simple as that. So next, what I'm going to do is set the primary, so primary actor tick, and .b can ever tick is going to be equal to true. Moving forward is going to be equal to, and over here, how did I not set equal to? But anyways, moving backwards is going to be equal to false, but first things first, above it, we are going to set the moving forward. So moving forward for There you go. Forward is also going to be equal to false. Now, going backwards here, interruptible is going to be equal to true, and the interruptible means will we be able, I have issues talking, if we are able to interrupt the enemy during its attack and all of that stuff, and we will see that. So last symbol index is equal to 0. And this is everything we need to do inside of the constructor. Over here, inside of the begin play, I'm going to call the super begin play. Begin play, there you go. And from here, active state, I'm going to set that to be equal to state idle. So that's going to be the current active state. Of course, we can set it to chase to whatever. For the moment, I'm going to set the target to be equal to u gameplay statics, and that's going to be get player pawn. And from here, I'm going to set the get world and 0. And this is going to get me the current player pawn that is in the world. Over here in the tick, I'm going to first call super tick, passing the delta time, which is going to call the super, or the function from the super, which is the combatant. And from here, we're going to say tick state machine, and there you go. And notice here, I call this function state machine. This is the state pattern. And that is the pattern that I talked about in the beginning that I said for what we're using enumerations. Of course, there is a better way how we can implement the state pattern. And you can just go and watch that section in the Academy. You will see it's called Design Patterns for Unreal Engine with C++ and Blueprints, which is, by the way, literally the only course online. I'm the first who has ever done it, to create design patterns with C++ for Unreal Engine. So yeah, kudos to me. Anyways, over here, we are going to create a switch and case, and the switch is going to be on the active state. There you go. And automatically it's going to give me all of the states. Now for the idle state over here, we are going to set the state to idle. There you go. And this is going to be executed. This is the function that's going to be executed when we are in the idle state. When we are in the chase close, we are going to say state chase close. There you go. In the chase far, we are going to say state chase far. Basically, we have the names of the functions. Over here in the attack, we are going to set that to the state attack. Duh. And for the stumble, let me just move this bad boy over here. So break goes down. It is going to be state stumble. There you go. Taunt, I'm not going to do that. You're going to do it. So your assignment is to code the taunt, and I'm going to simply comment it out. That is my assignment. And over here for the dead, I'm simply going to say state dead. There you go. So your assignment is going to code the taunt, and taunt, basically you can add some functionality to the player so that the player can taunt the enemy. That's all I'm going to say, because I also want to test you out. The point of these videos is also to test you out on your own knowledge, and that is how you are going to strive, and that is how you're going to improve. Now over here in our state idle, if I can find it first. Well, first things first, in our set state, what's gonna happen is we are going to change the state based on the parameter. And here I'm going to say if active state is not equal to state dead. So if we are currently not dead, then our active state is going to be equal to new state, which is the parameter that we have passed. Simple. We're simply testing if we are not dead. If the enemy is not dead, then set the active state to new state. Over here in the idle state, I am going to test if the target, so if we do have the target, which in our case is the player, and f vector colon distance between the target get actor location and the actor location. So get actor location, which is the location of our enemy. If that is less than or equal to 1, 2, 0, 0, 0, like that. So if that is the case, then I'm going to say target locked is equal to true, and our state, so set state is going to be state colon chase close. There you go. You can set this value however you want. I set an arbitrary value and I also hard coded it, which is not something that I recommend. But Fahir, why did you code it like that if you don't recommend it? Well, sometimes I want you to fix the things in the code that I did wrong, and that is also one of your assignments from the very start of this mini course or this tutorial. So I want you to fix, things that I have hard coded, things that you think can be coded better. So that is on you. So this is what I want you to do, okay? So if the distance, so if we do have the target and the distance between the target and the enemy is less than 1,200, I have issues. I don't know my daughter killed me last night or today, so yeah. Anyways, 1,200, if that is the case, target locked is true and we're going to chase the player. And over here in the state chase close, this is where the magic is going to happen. So first things first, we're going to calculate distance, which is going to be equal to f vector colon, and from here I'm going to say or calculate the distance, and the distance is going to be from the actor location, so actor location, which is the location of the enemy holding this script, and the target get actor location. There you go. So this is going to be the distance, or this is how we're going to calculate the distance. First, we're going to test if the distance is close enough for the enemy to attack. So if distance is less than or equal to 300, again, hard coding it, hint, hint, and if that is the case, I'm going to say here f vector, and I'm going to get the direction, so target direction, which is going to be equal to target get actor location, subtracting the get actor location, which is the location of the enemy. So subtracting the location from the player's location, the enemy location, this is going to give us the direction towards the player. Next, I'm going to go here and I'm going to create a float dot product, and that's going to be equal to f vector colon dot product. And from here, what I'm going to do is get actor forward vector and also colon, and then I'm going to say target direction dot save normal, or get the save normal. The save normal gets a normalized copy of the vector, checking if it's safe to do so based on the length, return 0. Basically, it is going to make sure that we get the normal direction of the target direction. Now, what is a dot product? Now, this is something that I see a lot of people have issues with, and they think it's complicated. Well, when you don't know what it is, it can get complicated. But basically, the dot product is an operation between two vectors, which returns a float number. We can see here, it's an operation between this vector, and we see it returns a float. Now, basically, the thing that we're calculating with the dot vector is the following. If the dot vector product or the returning value is greater than 0, then we are facing the same direction with basically these two vectors. So if the value is greater than 0, let me repeat that. If the value is greater than 0, we are facing the same direction. So these two are facing the same direction. If the product is equal to 0, then we are facing the perpendicular direction. And if it's less than the 0, we are facing the opposite direction. So that is basically what we are testing. And we're only interested if we're facing the correct or the same direction or not. So this is the only thing we are interested when it comes to the dot product. So now that we have the dot product, I'm simply going to test over here if the dot product, if it's greater than 0.95f, and from here, if we are not attacking, so if we're not attacking like that, I don't want to make a mistake like I did previously, and we are not stumbling, there you go, then we are going to attack passing here false. So if the dot product is greater than 0.95 and we're not attacking and we're not stumbling, then we are going to attack the player. Otherwise, if that is not the case, so over here, if the distance is not less than or equal to 300, so else, meaning here else, we are going to go here AI controller, and I'm going to say here star, which is a pointer, AI controller, and that's going to be equal to, we're going to cast from here AI controller, and we are going to cast the controller. There you go. So now if we do have the controls, we're going to say if AI controller, and from here is following a path, and notice the exclamation mark that I didn't put. So over here, if we are not following a path, then I'm going to say AI controller move to actor, and we're going to pass the target. And this is essentially what we need to do. So if the distance between the player over here, between the enemy and the player is less than 300 or equal to 300, we are going to attack the player with the enemy by facing the enemy in the direction of the player. So that is very, very important. If the enemy is here, for example, and the player is here, we can detect if the distance is less than or equal to 300. But if we just push the enemy forward to attack, he will attack here and miss the player who is over here. So that's why we need to rotate him like this, and then, only then, we attack the player. And we explain how by using the dot product. And if the dot product is greater than 0.95, there you go, then that means we are facing the exact same direction. So the enemy is facing the player. Bam, attack. Otherwise, make sure that the AI controller is not following a path. If he is not, then move towards the player target. And now we can test this out. So we can go here inside of our editor. And first, of course, we need to compile to make sure that we didn't do any oopsies. I didn't, write some weird code. And there we go, compile complete. And if I hit the play button now, the enemies, you see, they are coming towards the player when the distance between the player and the enemy, or the boss in this case, is close. And that we covered over here. So for the state chase. So if the distance is less than or equal to 300, then what's gonna happen? We are going to attack. But if the distance is not less than or equal to 300, then we are going to move towards the target. Now, we cannot test, well, basically, that's the only thing that we did. So that's the only thing that we also tested. We still did not create the attack to be able to test that. But this is essentially what we are doing in order to chase the player. And before we can do it one more time just to make sure that everything works. There you go. So they're getting close towards the player. And of course, this depends on the state, In the beginning, we set the state of the enemy to be idle, but you see over here, it is, as soon as the distance between the enemy and the player is, close enough for the enemy to start chasing him, it is going to chase him. Now, before I wrap this video up, we are going to go here inside of BP enemy, and we are going to attach a few things on the enemy, starting with the weapon over here, because now we have the weapon. So here for the static mesh of the weapon, I'm going to say WAP, and this one is going to be power hammer. And there you go, this is the one that we want, and it looks like an axe because this is a weird hammer for whatever reason. Now what I'm also going to do is attach a few animations. I say a few, like over here we have the attack animation, so I'm going to have here 1, 2, 3, 4, and 5. Later on we will have more animations here that I will attach, don't worry about that. But what we are going to do with the attack animation, so click here, we want the enemy melee attack 360 low montage. This is the one that we want. From here we want enemy melee attack backhand in place montage. There we go. For here we want the enemy melee attack downward montage. Voila, there you go. This one's going to be enemy melee attack horizontal. Voila. And from here we want the enemy melee cross. It's cross. Not course, it's cross. Why am I not spelling things correctly? Whatever. Anyways, you get the point. Now over here for the hit or take hit stumble backwards, which are the animations that are going to propel the enemy a little bit backwards when the player hits him. So what we're going to do here is we're going to add 5 elements in this array. And first things first, we want the front hit in place 1. And notice over here we have these multiple choices. Now we don't want this one with the Braxton over here. We want instead the one with the enemies. So again, front hit in place 1. There you go. So we want this one that says enemy. You see, this is the first one over here. It needs to be game, character, and then enemies. Again, this is the one that we want. So make sure that you select that animation. So front, hit, in place 1. So the enemy one. Again, it's really important that you do it like that. Then over here, front, hit, in place 2. And again, this one is for the enemy. And front, hit, in place 3. Again, select the one for the enemy. Next, we have front, hit, in place 4. There you go. I'm rhyming here. I'm throwing rhymes, man. Front, hit, in place 5. Last but not least, and make sure not the Braxton one, but the enemies one. There you go. Compile and save that. This is not going to change anything in terms of the enemies right now. They only have the weapon basically, and look at that. So they are now following the player. There you go. So this would be pretty much it in regards to this video. If you have any questions in regards to the code that we did over here, make sure that you ask, and when you ask, I will answer it. And in the next video, we will continue to code the, chase, far, attack, and all of that stuff. So, yep, I will see you guys in the next video. And when we hit the play button, this is the outcome that we have. So we have all of these bosses. Those two are not active because the distance between them and the player is too large. And notice here, when I hit this boss, I have a nice camera shake effect, and now I'm going to activate these two other bosses who are going to start attacking me with their range attacks. And unfortunately for YouTube, this is the end of the tutorial. I'm not going to code the boss here because that is exclusive for my Game Development Academy, and even the player is not coded to its fullest. So if you want to finish all of that, that is available, as I said, in my Academy. Link is down below. This was just a preview, so to say, what you can expect to see in my Academy, and this is something that nobody has ever created online, and I have plenty tutorials and courses like this where you will create advanced systems and truly learn how to code in C++ and Unreal Engine. So yeah, if you want that, check out the Academy and you will learn how to create this system and a bunch of other things along the way. Thank you for watching, and I will see you guys in the next video.